Every scrap of text you have ever written online has already been consumed. Every blog post, every forum argument, every bad recipe. By mid-2026, the world's most powerful AI models hit a hard, invisible ceiling. They ran out of human data to steal. The entire internet is dry. But instead of stopping, technology companies did something deeply unsettling. They started manufacturing reality. For a decade, building artificial intelligence was simple. You built a bigger vacuum cleaner, sucked up more of the internet, and fed it into a larger warehouse of computers. But that pipeline is dead. Lawsuits have locked down creative archives. Paywalls have blocked public forums, and the raw volume of human writing has simply been exhausted. Most people assume that AI will keep getting smarter simply because we are building bigger computers. But that is where everyone is wrong. Without clean data, a larger computer is just a high-powered engine running on an empty gas tank. To keep scaling, the industry had to pivot from harvesting human history to generating their own. To understand how we train machines on things that do not exist, we have to look back to 2019, long before the current AI boom. In industrial manufacturing, engineers faced a classic problem. How do you train a computer vision system to spot a dangerous defect on an assembly line when that defect only occurs once in a million runs? You cannot wait around for real-world failures to happen. Instead, engineers used physical simulation engines, the same systems that power hyper-realistic video games, to render millions of synthetic, mathematically perfect images of broken parts. This is physically based synthetic data. It was never a generative shortcut. It was a highly precise engineering solution to teach machines about physical realities they could rarely observe. When we try to teach AI advanced math, traditional training methods break down. If you feed a language model thousands of solved math problems from the internet, it does not actually learn how to do math. It simply learns to auto-complete the numbers based on what it has seen before. If you change a single digit, the system collapses. By late 2025, researchers realized they had to change their entire approach. Instead of giving models raw answers, they built synthetic datasets that forced the AI to compose mathematical logic symbolically. Think of it like a wind tunnel. If you want to design a supersonic wing, you do not just show an AI pictures of concords. You place a digital design inside a simulated wind tunnel governed by the immutable laws of fluid dynamics. The synthetic data generated in that tunnel is not fake. It is a perfect mathematical simulation of how air must behave. By training AI inside these synthetic logic engines, we teach them the rules of the game, not just the history of how it was played. This technique is solving a massive human inequality problem in AI development. The vast majority of global speech and language has zero digital footprint. If an AI only trains on scraped internet data, it becomes culturally deaf to billions of people. In late 2025, startups began bypassing this barrier entirely by synthesizing voice data for underserved, low-resource languages. By taking a tiny, high-quality sample of a rare dialect, developers can mathematically reconstruct entire libraries of spoken conversations that never existed online. They are not fabricating culture. They are using synthetic generators to build digital bridges for communities the internet ignored. But this engineering pivot carries a terrifying systemic risk. When an AI is trained on synthetic data created by another AI, we enter a dangerous loop known as model collapse. Think of it like making a photocopy of a photocopy. The first copy is clear. The 10th copy is slightly blurred. By the 100th copy, the original image has degraded into useless static. Without the messy, unpredictable variety of real human behavior to anchor them, models trained on synthetic data slowly drift away from reality. They forget the rare, brilliant edge cases of human expression and collapse into a sterile, repetitive feedback loop of their own making. The stakes are highest in the field of scientific research. Today, algorithms are generating synthetic datasets to predict how new drugs will interact with the human body or how materials will behave under extreme pressure. But if researchers publish scientific papers based on synthetic experiments without absolute, transparent verification, we risk polluting the global scientific record. A single uncorrected hallucination in a synthetic dataset can cascade through generations of future research. The ethical duty of scientists has shifted. They can no longer just trust the data output. They must actively build mathematical guardrails to ensure their simulations remain anchored to physical truth. We are entering an era where the boundary between the natural world and the simulated world is permanently blurring. The internet is no longer a historical record of what humanity has written, drawn, and thought. It is becoming a closed-loop laboratory where machines continuously teach other machines under the watchful eyes of human engineers. We are no longer training AI to understand our world. We are building a new world out of calculations and asking both the machines and ourselves to live in it.